All right, so in this video, we are given a rectangular cardboard box, and we are basically going to cut out congruent squares from the four corners of this rectangle that's 30 by 20 centimeters. And if we cut out these squares and then fold up these four flaps, it will create an open top box. And that open top box will have a volume of 1008 centimeter cube. And we need to find the dimensions of the squares that have to be cut out to get this exact volume. So I'm just going to label the length and width of these congruent squares as basically x. And then we know that the volume equation for a cuboid is length times width times height. So if we look at this cuboid over here that gets cut out, basically this little diagram here, or this dotted lines here, is the base of this cuboid. The length of this is just 30 minus 2 times x. And the width is just 20 minus 2x, because we're subtracting out the two x's from the congruent squares that we've cut out. And then the height of this box is just going to be x, because when this flap gets folded out, this will be the height of the box, which will be x. We want to fill in all this information into this formula. So 1008 is the volume, length is 30 minus 2x, and width is 20 minus 2x, and the height is x. So now I just want to solve this equation for x, and that's going to give me my answer. So 1008, I'm going to expand these two brackets. I'll also write this x in the front here just to make things a bit easier. That's 600 minus 60x minus 40x plus 4x squared. And then I'll combine like terms inside the bracket. So that's 60 minus 600 minus 100x plus 4x squared. And then I'll multiply this x into this. 600x minus 100x squared plus 4x cubed. I'm going to rewrite this in order just to make things a bit easier. So 4x cubed minus 100x squared plus 600x. And then I'll move the 1008 to the other side to make it equal to 0. So 4x cubed minus 100x squared plus 600x minus 1008. So now I want to factor this equation. I can actually common factor out a 4 over here. X cubed minus 25x squared plus 150x minus 252. And now I can factor this using my factor theorem. So I'll test multiples of this number at the end. I'll start with f of 1, f of 2, and f of 3. So 1 cubed minus 25 times 1 squared plus 150 times 1 minus 252. F of 1 is negative 126, so that's no good. I'll try f of 2 next. F of 2 is negative 44, so that's no good either. Remember, I want to get 0. I'll go to f of 3 next, which I believe is a multiple of 252, although I'm not 100% sure. Find out soon though with the calculation. And f of 3 is 0, so I can do my synthetic division here with f of 3. I got a 3, and my coefficients here, 1, negative 25, 150, negative 252. Bring down the first term, multiply these two, subtract these two, or add them, I guess, technically. Multiply these two, Add those two, 150 minus 66 is 84. Multiply those two, 252, and I get a remainder of 0. So in factored form, I can write this equals 0 equals to 4x minus 3. And then this is a quadratic equation now, x squared minus 22x plus 84. Now I need to factor this further. So what multiplies to 84 and adds to negative 22? 12 times something, I think, is possible. 12 times 7 doesn't work. 14 times 6 does not work either. So this one's actually not possible. You can't factor this over here like this, which means we got to do quadratic formula. So over here, my solution is just x equals to 3. Over here, I'm going to do quadratic formula. So x equals to 22 plus or minus root of negative 22 squared minus 4 times 1 times 84 divided by 2 times 1, which is 22 plus or minus, I'll do that whole calculation in my calculator. I get 148, and now I'll calculate this all with my calculator. So 22 plus a root of 148 over 2 is just 17.1 if I round to one decimal place. And 4.9. So I have three possible answers for x in this question, but I have to test the validity of all these three answers to make sure whether they're good or not. Let's start testing x equals to 3. If I test x equals to 3, I know my length is 30 minus 2 times x. So my length is 30 minus 2 times 3, which is 24 centimeters. My width is 20 minus 2 times 3, which is 14 centimeters. And my height is just x, which is just 3 centimeters. So this answer is perfectly logical. X can equal to 3, so the height of the box can equal to 3. Let's test the second solution of 17.1. My length is 30 minus 2 times 17.1, which is a negative number. So it is negative 4.2 centimeters. It's impossible to have a negative length. So this is not possible, which means that 17.1 is not a good solution. And let's go to the third solution of 4.9. X equals to 4.9. So our length is 30 minus 2 times 4.9, which is just 20.2 centimeters. That's fine. Width is just 20 minus 2 times 4.9, just 10.2 centimeters. That one's also good. And the height is just x, which is just 4.9 centimeters. So all of these three are good. So we have two possible solutions to this question. X equals to 3 centimeters or x equals to 4.9 centimeters.